We're talking about ratios, proportions, and rates of change. And we want to find the percent change and solve problems involving percent change. So when we're doing this, we want to find the percent over 100. So if we think about percentages, these are going to be like 80%, okay, 70%. If we compare them to 100, we know that this is going to be, these values are smaller than 100. So when we're comparing our percent increase to the original value, original price, usually that's going to be smaller than what we look at 100% here, but not always. And we're looking at our percent decrease. We want to have how much the value decreases over the original price, just like we would have the percentage over like 100 would be the full price. So let's just take a couple examples just to look at it. So if lunch was $1.50 last year and is $2 this year, what is the percent of increase of the cost of the lunch? So when we're looking at this right now, we want to see how much did it increase total. So what was the original price? The original price was $1.50, right? And the new price here is $2. So how much did it increase to go from $1.50 to $2? So it increased 50 cents. So when we're looking at our equation here, we want the percent or the amount that it increased. So how much did it increase? It increased 50 cents. And then we want the original price. So the original price in this case was last year's lunch was $1.50. So that's how much it was last year. So then we're going to set that equal to some value X that we want to find. And we're always going to have 100 written down there. So now we have it set up in a proportion, and then we can solve it to figure out what X will be. So we can take our extremes, which is going to be 0.5 or 0.50 times 100. And we're going to set that equal to our means, which is 1.5x. And then we can end up using our calculator for this one. But in order to get x by itself, we have to divide both sides by 1.5. And then we get, with our calculator, if we multiply 0.5 times 100 and then divide by 1.5.
Mr. Grewell.
Yes.
Sorry for the interruption. Could you please send Abby, Jack, and Eddie to the main office, please?
Yes.
Thank you.
So that is a 33% increase. All right. Make sense? Okay. Look at 13. Sam paid $12,500 for a car and can only get $8,000 for it if she sells it. What is the percent of increase or decrease in her vehicle? First of all, is this going to be percent increase or decrease? What? Decrease. Okay, because we're starting at 12,500, so that's going to be our starting point. And then we're going to end at 8,000. So this is going to be a decrease. So 12,000 minus 8,500, and we end up with 45. That's not right. I wrote that down wrong. Oh, that is right. 4,500.
It's only 8,000, not 8,500.
Oh, I wrote this down wrong. This is 12,500.
Yeah.
And then this is 8,000. That's why I had it wrong, written down wrong. So this is 12,500, and this is 8,000, and that is equal to 4,500. All right, and what did we say that was going to be? Increase or decrease?
Decrease.
Decrease. Does that change our equation at all? The original price still goes in the bottom on the left. Original price still on the bottom on the left. 100 on the bottom on the right. 100 on the bottom on the right. Increase is over here above the original price. Decrease is above the original price. There you go. And the percent is still there. So it doesn't matter if it's increase or decrease other than in the context of the question, right? The equation that we're going to use is still the same. So we're still going to start with the original price, which is what?
12,500.
12,500. And we always know that 100 is going to be in the denominator over there. How much did it decrease? 4,500. And what are we trying to find? Trying to find our X up there, or our percent, right? Now, we can do the means and extremes, right? Cross multiply, get that, and then we say, oh, there's 1.5 next to the X. But what do you guys notice? Where's the 1.5 over here? Already in the denominator. Where's the 1.5 over here? So even though we cross multiplied, we brought the 1.5 over, and then we're like, oh wait, we got to take it back. So it ended up in the same spot it was originally. So what could we do here that could maybe take one step away? How could we get X by itself?
Multiply by 100.
Multiply 100. We got division. So if I multiply by 100 over here and multiply by 100 over here, that is going to get X by itself because those are going to cancel. So that eliminates one of those steps, so I can get done a little bit quicker. So those eliminate, and we were left with X. And then here, when we do our math, we can use our calculator for this. And we end up getting 36% decrease. So X is equal to 36 is a decrease.